An oblique asymptote, it's also known as a slant asymptote. It occurs whenever the degree of the numerator is larger than the degree in the denominator. So here's an example. The degree in the numerator is larger than the degree in the denominator. So that means we're going to have an oblique asymptote. We're not going to have a horizontal asymptote, but we'll have an oblique one. The way that we find it is we do synthetic division. So I'm going to do synthetic division. I'm going to get 1, -1, and -6. And I'm going to divide it by this linear. So what will go out here? So I equal this to 0 and solve. So I'll get x equals 1. So that will go up here. Now we're going to use synthetic division. I bring down the first number. I multiply to get 1. Add to get 0. Multiply, I get 0. Combine, I get -6. Now, I started out with a quadratic. What do I end up with? A linear. So if my answer is a linear, that means this is your x term, this is your constant, the 0, and this is just remainder. So we don't have to pay attention to that. So my equation is y equals x. So that is my oblique asymptote. And I'll go ahead and graph it over here on my graph. My oblique asymptote is y equals x. Okay. And the way we find the other components is the same thing that we did last week. So I'm going to go ahead and factor my numerator. If you do an eye chart, what are two numbers that will multiply to -6 but add to -1? Exactly. So I'm going to write this as x minus 3 and x plus 2. Okay, are there any holes? No holes because nothing canceled out, okay? No common factors. So my domain, what can x not be? 1, because if you plug in a 1 here, you'll get 0 in the denominator. We can't have that. That means we have a vertical asymptote at 1. What will my zeros be? 3 from this factor and -2 from the other factor. My y-intercept is 0, 6. We know this by plugging in zeros everywhere. We're just left with -6 divided by -1, which is 6. Okay, now let's do our interval work. When we do our interval work, you're just looking at the vertical asymptote and your zeros. So I have -2, 1, and 3. What did you guys get for the intervals? Actually, let me show you guys a quick way to do this. Okay, so a quick way to do your intervals is to put it in factored form. So this is our rational in factored form. So we're going to plug in a number that's smaller than -2. So let's plug in a -3. If I put in a -3 here, here, and here, right here, I'll get a negative in this parentheses. Here, I'll get a negative in the parentheses, and here, I'll get a negative. That's 3 negatives. If you have an odd number of negatives, it'll just be negative. All right, now let's try plugging in a number between -2 and 1. What should I plug in? 0? Perfect. Okay, so if I plug in a 0, let's see what I will get. I'll get a negative here, a positive here, and a negative here. Do I have an even number of negatives? Yep, this is a negative and this is a negative. That's 2 negatives. That's even. That will be positive. Okay, now let's plug in a number between 1 and 3. What number did you guys test? 2? Okay, so if I plug in a 2, I get negative, positive, positive. I have 1 negative, 1 is odd. So what does that mean? It'll be negative. Okay, now let's plug in a number that's bigger than 3. What did you guys plug in? 4. Okay, so if I plug in a 4, all of these are positives. Okay, so let's go ahead and graph this. I have a vertical asymptote at 1, so right here. I have a 0 at 3 and -2 here and here. All right, so let's go ahead and graph this. It says that on the left side of -2, I have to be negative. So I'm going to be down here. I'll be down here. Between -2 and 1, I have to be positive. So I'm going to go up. At 1, between 1 and 3, I have to be negative. So I have to be down here. But once I get to 3, I'm going to become positive. So I'll be up here. So that is what your graph looks like. What are the possible rational zeros? Yep, we have to get factors of 30. So plus or minus 1, 2, 3, 5, 6. Tell me. We skipped 1. 10, 15, and good. These are all of the possibilities that can be a 0. These are the rational possibilities. So I'm going to give you a hint. I already tested some of these. I already know that 2 is one of them. So try to find the other ones. I'm telling you that 2 is one of the zeros. How many should there be total? 3, because it's a third degree polynomial. All right, good job, guys. A lot of you guys got this far. That means I started out with the cubic. After I did synthetic division, what is this row? Good, it's quadratic. So guys, that means this is x squared minus 2x minus 15. Did you guys factor after this? What are two numbers that multiply to -15 add to -2? Good. So that means your factors are x minus 5 and x plus 3, which means what are your zeros? 5 and -3. Perfect. Okay, so guys, to answer these questions, it's easy to look at it in factored form. So guys, if I had this 0, 2 in factored form, how would you write it? Exactly, x minus 2. The 5 in factored form is right here, x minus 5, and then x plus 3. So that is the numerator factored. Do you guys know how to factor this denominator? It'll be x plus 4 and x minus 4. Does anything cancel out? No, so we don't have any holes. So what can my domain not be? Exactly. -4 and 4, that means that's where my vertical asymptotes are. We set the denominator equal to 0 and solved it. Okay, now let's do, well, the y-intercept. What will the y-intercept be? It would be 30 over -16, which will simplify to -15 over 8, which is approximately -1.875. Okay, so let's talk about the interval work. We're going to go to oblique asymptote, but we're going to do the interval work. We're going to have our vertical asymptote, so -4 and 4, and then our zeros, -3, 2, and 5. I'm going to pause here and have you guys tell me what the interval will be. All right, I'll give you guys a hint to start you off. We want to test a number less than -4. So what do you guys want to plug in? -5. Okay, so -5 here. And all of these x's, we're going to plug in a -5. So up here, I get a negative. Here, I get a negative. This is a negative. This one's negative. And this one's negative. How many negatives did I get? 5 of them. That's odd. That means this is negative. Good. So guys, for the next one, test a number such as like -3.5. Okay. So So if you put in a negative 3.5 for all of these x values, let's see what you're going to get. This will be negative. This will be negative, negative, negative. This one's positive. How many odds do how many negatives do I have? 4. That's even. So that means this will be a positive interval. Okay, so you should have gotten minus, plus, minus, plus. That is our interval. Okay, so I'm going to go ahead and put everything we know on here, and then we're going to go back and do the oblique. Now, guys, your oblique, even if you did have a hole, so just pretend you had x minus 2 and those canceled out. When you do your synthetic division for oblique asymptote, you do it on the original, not after you canceled out, okay? That's the only thing that we do before canceling out is the oblique asymptote. So we're going to factor 1, -4, -11, and 30. What will go in here? We're looking at these linears. So I'll do this one first. I'll plug in a -4 first, and then we'll do the synthetic division, and then we'll do the next one. Okay, so I bring down the 1 and multiply, we get -4. Add, we get -8. Multiply, we get 32. 32 and -11 is 21. Multiply by 4, -4, and you get -84. Add those, you get -54. Okay, we're going to do synthetic division again. Guys, I started with the cubic. What is this right here? This is quadratic, because we started out with degree 3, so now we're at degree 2. We're going to do synthetic division one more time, this time with this linear one. So that'll be a 4 that we put in here. We multiply. -16, this will be 5, multiply, -20, -74. Okay, so guys, what is this answer? We went from cubic, quadratic, what is this one? Linear. So guys, if it's linear, then that means this will be an x -4. All of this is just extra stuff. So that means my oblique asymptote is at y equals x -4. So I'm going to go ahead and plot that. So now let's plot everything that we know. I have an oblique asymptote right here. This is the equation, x -4. So this is what your oblique asymptote will look like. All right, we have a vertical asymptote at -4 and also at +4. And I have a 0 at 2, 5, and -3. My y-intercept is at -1.87 or -1.875 thousandths. Okay, so let's go ahead and graph this. Oh, my x value is right here. All right, so according to my interval chart, when I'm less than -4, I need to be negative. So that means I should be down here, because this is -4 right here. So I need to be on the negative side. Between -4 and -3, I need to be positive, so I'll be up here. However, after -3, I have to become negative. And that will let me go through those points. After 2, I'm going to be positive again. And then after 4, I must be negative. So I'm going to be down here on the negative side. But factor 5, I'm going to be positive. So once I hit this x-intercept at 5, I'm positive. So that is what my graph looks like. Okay, you can keep working on this one. So if you factor the numerator, if you split this down the middle, what can these both be divided by? X squared, so I'm left with x minus 4. What can both of these be divided by? 3, so I'm left with x minus 4. So whatever is the same will go in one parentheses, and whatever is on the outside will go in your other parentheses. Okay, so that's this numerator factored. Okay, and our denominator, what can these both be divided by? So this can be x times x minus 4. Okay, so guys, do y'all see what cancels? Those cancel. That means I have a whole. I have a whole at, let's set it equal to 0 and solve. I have a whole at the x value 4. What is the y value of my whole? We have to plug in 4s into what's left over. So I have x squared plus 3 over x left over. Let's plug in a 4 to see the y value of that whole. So this becomes 19 over 4. Can someone put that in the calculator and see what that is? Thank you, 4.75. So that's where your whole is. Okay, now looking at our new equation, we can answer the rest of these questions except for the oblique question. So this is the new function we're looking at. So guys, what can my domain not be? Cannot be 0. That means I have an asymptote, vertical asymptote at x equals 0. Okay, my zeros. What are my zeros, guys? We set the numerator equal to 0 and I solve. So guys, I have x squared plus 3 and equal it to 0. I get negative 3, and then I square root both sides. I get x is plus or minus I square root of 3. So guys, I don't have any real zeros, so I'm just going to put none for this. All right. So let's go ahead and do my interval work. So we're going to look at, I don't have any zeros, but I have a vertical asymptote at 0, x equals 0. Okay, so go ahead and do the interval. Good. All right, so if you plug in a number like negative 1 and negative 1, this will become negative. And if you plug in a positive number like plus and plus or positive 1s, you get a positive. So those are my intervals. Okay, so let's go ahead and graph what we have so far, and then we can find the oblique asymptote. Okay, so I have a vertical asymptote right here at x equals 0. That's my vertical asymptote. I have a whole at 4 and 4.75. So 4, I have a hole about right here in my graph. And I have do I have a y-intercept? No. Or yes, I do. No, I don't. I don't have one. I'm going to put none for y-intercept. Okay, now let's find that oblique asymptote. We're going to use synthetic division. Okay, so when I do synthetic division, I'm going to have 1, negative 4, 3, and negative 12. Remember, we factored this as x times x minus 4. If you set these both equal to 0 and solve, you'll get 0 for one of them and then 4 for the other one. So that's what we're going to use out here. So bring this down. We get 0, combine, 0, combine, 0, combine. Okay? The next one that we're doing synthetic division is, if you equal this to 0 and solve, you get 4. So I'm going to put 4 here. So this row, we started out with a cubic. This one is quadratic, so my answer is going to be linear. And you could really just stop here because this is all that matters. This is x, this is your constant, that's just extra. Kept going, this is just extra. So my oblique asymptote is at y equals x. Okay, so let me graph that on here. My oblique asymptote looks like this. Okay, now let's look at my interval. When I am less than 0, I have to be negative, so I'll be down here. When I'm greater than 0, I have to be positive, so I look on this side. And don't go through your hole. So sometimes your numerator degree is going to be twice. It's going to be 2 times bigger or twice as much as the denominator. So notice this is a cubic and this is a linear. The difference is 2. It's greater than the denominator by 2. So when you do that, your answer is going to be a quadratic, okay? So let's go ahead and find the oblique asymptote. I'll let you guys find the other things. Equal this to 0 and solve. So we get x equals 1. That's what we'll put out here. This is coefficient of 1. We're missing the squared term, the linear term, and the constant term. So those are going to be 3 zeros there. Bring this down, we get 1, multiply, add, multiply, add, multiply, add. So we get all 1s. Okay, so guys, remember, we started off with x cubed. Now my answer is a quadratic, x squared. So that means my oblique asymptote is y equals, this is 1x squared plus 1x plus 1. That's just extra. So my oblique asymptote is y equals x squared plus x plus 1. It will look something like this. Well, I know the y-intercept would be at 1. So it's going to look something like this. Just a rough sketch. Okay, I'm going to let you guys finish the domain, vertical asymptote, zeros, interval work, and y-intercept, and then we'll come back and graph it together. All right, so for the domain, you should have said x cannot be 1, because if it was, you would get 0 in the denominator. Your vertical asymptote is at 1. Your zeros, where did you guys say the zeros were? Do you have zeros? How do you find your zeros? Yep, you set the numerator equal to 0. So what does x have to be so that when you cube it, you get 0? 0. Okay, and your y-intercept? 0. Okay, so let's do our interval work real quick. You have a 0 at 0 and a vertical asymptote at 1. So if I plug in a number such as -1, I'll get a negative in the numerator and the denominator. That would be positive. If I plug in a number like 0.5, I would be negative. If I plug in a number bigger than 1, I'll be positive. Okay. My oblique asymptote, we already graphed it. So let's go ahead and put my vertical asymptote at 1. I have a 0 right here, and that's also my y-intercept. Okay, so when I'm on the left side of 0, I need to be positive. So my graph, and sorry, let me draw my oblique asymptote with a dash so that you know that I'm talking about an asymptote. Okay, so my graph will be positive on the left side. Once it gets past 0, between 0 and 1, it has to be negative. So I'm going to get very close to this asymptote. I'm negative. When I pass one, I'm going to be positive. So that'll be up here. And that's what it looks like.